So today we're going to talk about part of the 024 notes on rational functions. So you'll have an overview of rational functions, and then we're going to continue to work on these ideas when we come back face to face. I know that they're challenging. So a rational function is a function that can be written as the quotient of two polynomial functions, p of x and q of x. So we just studied polynomial functions, so you should know a lot about them. Now it's just one polynomial function on top of another polynomial function. And as long as q of x is not 0, because we know that we can't divide a fraction by 0, and p and x and q of x have no common factors. Something different is going to happen when they have common factors. We'll see that when we're back face to face. But for now, these are rational functions. So you've already looked at them. You've looked at the parent function. You've looked at moving the parent function around. You've looked at some of these on a graphing calculator. So now we're going to start to pick them apart. So today we're going to look at finding x and y intercepts. And we're going to also practice some division. And then next class, we're going to look at their vertical and horizontal asymptotes. And then part C, kind of our third part, so Wednesday, Thursday, Friday of these videos, part C, we're going to look at just graphing them step by step. All right, so the first thing to notice is there is a value for x that the denominator will not allow. So the value that x cannot be is -1, because if I plug in -1 plus 1 gives me 0 in the denominator. So for these first couple examples, we're just talking about what can x not be. So in this second example, the denominator is a quadratic, and I know how to factor quadratics. This is a trinomial, and this would be a diamond method. I'm looking for the factors of -6 that add up to -1. So x minus 3, x plus 2. So now if those two factors are in the denominator, what can x not be equal to? +3 here and -2 here, because -2 plus 2 would give me 0. This third example is already in factored form. What could x not be down here? So how would I get 0? If I plug in +1, so x cannot be 1 because 1 minus 1 would give me 0. So just thinking about rational functions have x values that we have to exclude. Those are going to end up forming some asymptotes on our graph. All right, so here is a quick summary, and we'll practice a lot. We're going to spread these notes over 3 days to digest piece by piece. So graphing a rational function can be tricky, but not if we carefully follow the same procedure each time. So there's two major things we're going to find. The x and y intercepts, so that's kind of day 1. The asymptotes, it's kind of day 2. And then if we want to find more points, all we need to do is plug in x values. So if I want to evaluate a function, I can plug in different values for x. There's also two major things to remember. These are functions, so they will always pass the vertical line test. So that means that if I already have part of my graph in this quadrant, I'm never going to have anything else down below it, right? Because this would fails the vertical line test, right? So you can never have them on top of each other. You're either going to have another section over here, or they're going to be opposite each other, one up and one down. And also, graphs are always going to hug the asymptotes. So when we look at asymptotes, graphs get closer and closer and closer to those asymptotes, and that's going to help make the shape of our graph. So today we're going to look at first finding intercepts and then reviewing how to divide polynomials. So part A, how do we find the intercepts? To find the y-intercept, you're plugging in 0 for x. That's what computing f of 0 means. Plug in 0 for x. So let's go through this first column and find the y-intercept for each of these functions. So if I plug in 0, I get 2 plus 0 in the numerator and 0 minus 9 in the denominator. And I think you can see that reduces to -2/9. So my y-intercept is 0, comma, negative 2/9. So I would plot that point on my graph if I was graphing this function. All right, the next example, when I plug in 0 for x, I get 0 over 0 squared minus 9, which is 0 divided by negative 9. And 0 divided by any number is 0. If you ever forget that, you double check on your calculator. 0 divided by negative 9 is 0. If I had had the negative 9 in the numerator and I tried to divide by 0, I can't, right? We cannot divide by 0. But 0 divided by negative 9 is 0. So 0, comma 0 is my y-intercept. H of x, this function, when I plug in 0, 0 squared plus 6 times 0 plus 5 over 0 minus 8. I think you can see the pattern. All the x terms go away, and you're left with, in this case, negative 5/8. So if you have one negative, a positive divided by a negative is a negative. 0, negative 5/8. I just write the negative in front of the fraction. If this had been a negative divided by a negative, that becomes a positive, right? So then I would have had positive 5/8. But one negative in the problem just gives me negative as my solution. All right, and then the last one, so the problem this time is I get 0 in the denominator, right? Because 0 cubed minus 2 times 0 squared is 0. 1 divided by 0 is undefined, so there are no y-intercepts for this problem. So it's okay, sometimes there might not be any y-intercept. If you can't plug in 0, there's no y-intercepts. All right, so the other intercept that you need to know how to find is the x-intercept. So basically plug in 0 this time for y. So set the equation equal to 0 and solve for x. If I put 0 over here, to solve for x, my first step would be to multiply this x minus 9 to the other side, right? So I'd get 0 equals 2 plus x. So if 0 equals 2 plus x, the shortcut, in other words, let f of x equal 0, but in the case of rational functions, we can just set the numerator equal to 0 and solve. So this is kind of a shortcut, right? You're plugging in 0 for y, but what's really happening is this side of the equation goes away, 0, right? Because this is y equals. The denominator gets multiplied to the other side, 0, and I get 0 equals the numerator every time. 0 equals the numerator. So if 0 equals the numerator, what would x be when you solve this equation? Subtract 2 to the other side, right? So my x-intercept is at negative 2, comma 0. I plugged in 0 for y. I got negative 2 for x. Over here, remember, I plugged in 0 for x, and I got negative 2/9 for y. If you look at an x-intercept, right, anywhere on the x-axis, the y value will always be 0. So an x-intercept should always have a y value of 0. So in g of x, if I set the function equal to 0, I'm really just looking at the numerator, so x has to be 0. It's already solved. So it kind of makes sense if 0, 0 is an x-intercept, that 0, 0 is also the y-intercept, right? They both would be at the origin, same point. Okay, so the last two for solving for intercepts. This time, I'm going to set the numerator x squared plus 6x plus 5 equal to 0. So this is where you need your knowledge of polynomial functions. I know that this factors, I'm looking for the factors of 5 that have to add up to 6. X plus 5, x plus 1. So my two x-intercepts are at negative 5 and negative 1. Negative 5, 0, negative 1, 0. All right, and now this last function what happens? I set the numerator equal to 0. Can 1 ever equal 0? No. So kind of in the case over here, there was no y-intercept. There might also be no x-intercept. They don't always happen in the same function, but it's a good clue that that might happen. So you might have no x-intercept. So now you are going to continue on. So there's a second video I'm going to talk about division methods in a minute, but you can use your knowledge of x and y intercepts before you do the division part to maybe do this part of the guided practice, 0 to 5. You're going to have to skip ahead in your notebook to 0 to 5. These 4 questions are identical to what we just did. Plug in 0 for x, then plug in 0 for y. So you may want to do those sequentially. So then your next video is going to look at these 4 division problems. And also on the back of 0 to 5, you'll find 4 division problems. All right, so 0 to 5 is what's getting submitted today, and 0 to 4 is just where we're taking our notes. So now you're going to video number 2.